Hey, good Sunday afternoon, everybody. Brian Bledsoe with you here, host of the Desert Farmer Podcast. Thanks so much for being with me this afternoon. Greatly appreciate your listenership. And I also want to say that we've obviously changed the medium here with the Desert Farmer Podcast, where we used to just simply be audio. And I made that decision quite a while ago to do stuff more visual, simply because we're talking about maps. And I mean, I can sit here and verbally try to paint a picture of what I'm looking at so you can understand it, or I can just simply show you. So if you have feedback for me in the fact that you appreciate this medium that I upload on YouTube more than just simply the audio version, please let me know, because I know I appreciate it more and I enjoy it more because I like to be able to actually show you what I'm talking about. I think that it's just simply more meaningful, and the overall message can be a whole lot more actionable. So with that in mind, let me know. Okay. First and foremost, and I'm not going to talk a whole lot about this to get things going. It's obviously been hot. I'm so sick of talking and hearing about the heat. Yes, it's hot. We had temperatures around, 110 today. St. Francis, Kansas, Ray, Yuma, Colorado, right up there around 108, 109. Lamar, Colorado was 109. Leota, Kansas, about 111. I think Ulysses, Kansas, the last time I checked, was right there at about 111 degrees. And you drop farther south and you lose some of that heat a little bit. But it was still in Lubbock today, right around 100 degrees. So again, I know it's super hot out there. Nothing we can do about it. We just simply have to pivot and do the best we can with what we have. And I kind of, was thinking about this question a little bit earlier. Is it more heartbreaking to not have enough moisture at all to start the year, or through the middle part of the year to where everything failed? Or is it more heartbreaking to get good moisture when you actually need it early on and then see the whole damn thing burn up? I think it both sucks. Both of them suck. All right, both of them. There's no way around that. And when I look at least in our specific my specific ranch, all right, there in eastern Colorado, we've had as a whole between about 2 and 2.5 inches of moisture. This is total liquid so far this year on the ranch. Now, we had great winter pasture. So we've been very creative about moving the cattle around and doing the best we can. But damn it, we need a rain, man. And there's been some big rains around us, that we've missed out on, some 2 and 3 inch rains that were pretty close by. And it's just one of those things. It literally will not rain where it needs to in that one spot to be beneficial. And I know a lot of you are in the same boat that I am. All right. I know how that goes, where there's really no rhyme or reason for it. It's just the way it is. And I've seen it on the exact opposite side of the coin, where, we've gotten a lot of moisture and other folks right next to us haven't been as fortunate. So, to simply put, that's just life in the high desert. We know this. We're no stranger to it. And as much as it sucks that we have to deal with this stuff from time to time, or back to back years, obviously we didn't have that last year, but we've seen back to back years in the past where it's been a problem, sometimes 2, 3, 4 years in a row where it's been a problem. But this is something that's never going to change. It's never going to change for agriculture in the West and the Southwest High Plains. Now, if you go farther east, obviously they're in a better position to get some rain. They've had a lot of rain in areas farther east, but the heat that's coming through right now and the dryness is putting a lot of stress on the crops that were really looking good. So weather is almost always a problem at one particular time or another during the course of the year. And in my mind, it's never been more important to be diversified, to be able to pivot to different things if they're working better, and do the best we can to plan for the future. Because if you would have told me, say back in late winter and early spring, all right, that this map would have looked like this by the time we got to late July, I probably wouldn't have put a whole lot of credence into it. And I'm bringing that up for a couple of different areas. All right. This area in particular, historically, has almost always fared very, very well when we've had a transition from a La Nina to an El Nino. The Western High Plains have, and there have been a couple of exceptions in previous years, but with this type of shift, and it was a seismic shift and a very rapid seismic shift from the La Nina that we had during the winter to the El Nino. And a lot of times when you see that, things light up in the Western High Plains. And it just hasn't been the case in a sustained fashion. Now, there have been some areas here in western parts of Kansas that have done very well. Scott City, Kansas has done very well. Dighton, Kansas. There were some areas up around Colby and Oakley that were very dry early. And then bam, all of a sudden they got about, almost a year's worth of water in about a 2-week period of time. But there are some areas here in Southwest Kansas, by the time you get down toward Ulysses and Liberal and Hugoton and southward toward Guyman, Oklahoma. I think I mentioned this 10 days ago in our last episode that Guyman, Oklahoma, that's where the term the Dust Bowl was created and forged into existence with the droughts that occurred back in the 30s in that part of the world. So it's not unheard of that we're dry. It's just that the pattern shift simply did not behave according to history. And that can happen, obviously. And the models weren't showing that either. So this is what I'm trying to be is very transparent within this forecasting that we do, is that it's rarely ever a perfect science. And sometimes it can basically go the opposite direction, not unheard of. And that's one of the reasons why I always caution that I hate La Nina and I hate El Nino for these reasons, because there are almost always extremes. There are always different little nuances that can buck some historical trend or whatever. And we do the best we can with what we have to work with to try to navigate that situation accordingly. But it's just been super rough. And if you're the first, this is the first time you've ever seen this type of a map or digested it, all right, this climate division in Southeast Colorado is very diverse, all right? It runs from, say, up around Salida all the way out towards Springfield. And that is a huge difference when it comes to weather. But for the most part, Southeast Colorado has just been absolutely, a struggle to get decent sustained rain. So that 130 that you see right there, that means that out of the past 134 years, there have only been 4 years, all right, from January 1 to July 26th that have been drier than what we have just witnessed. Only 2 years have been drier in this climate division in northeast portions of Wyoming. 10 years, only 10 years have been drier. And that's only because here in western Nebraska, around Chadron, Scottsbluff, Alliance, down toward Kimball, Sidney, those areas right there actually picked up some better rain over the past, say, 30 days or so. It hasn't been ideal, but it's been better. And then you have to go down here to Texas. And a lot of areas down here in central and southern parts of Texas have done very well off and on for this 7-month period, especially from April through now. And we got a giant rain down here, flooding rain, anywhere from, say, 10 to 30 inches, about 12 days to 2 weeks ago. This area has been fairly wet during the course of the year until here recently when things started to shut off. Either side of that, not as fortunate. Most of Montana has done better, especially central, west, and southwest Montana. So you can see that if you just look at this, there's more brown on this map than there is green. And I think most folks that I talk to would say that's definitely accurate. Don't get bogged down into the numbers, okay? The numbers are silly. We can get a little bit of a closer viewpoint in those numbers. You can see right here over southeast Colorado, north central New Mexico. But if you go into southwestern New Mexico, you've gotten better monsoonal moisture here, all right? This, again, is from right through the first, 7 months of this year. We've been much, much wetter here and over to here. So, and this, I really don't even think this does it justice, that, as dry as it's been in the western half of Oklahoma, I'm sure a lot of you guys are thinking, man, how could it have been any drier in some places than this? Well, It obviously can. Now, the past 30 days have really put a stress on some things because we have seen just really dry weather, for the most part. And I'm kind of roughly drawing this sketch. There have been some better spots in here in places, but for the most part, it has been a real struggle where some areas have been, less than 30% of average in terms of total moisture, for the past 30 days or so. So there have been a lot fewer haves than have-nots in this area. And then this area down here is obviously, in reference to that upper low that made its way from east to west across Texas. So enough about the heat, enough about the dryness. I'll show you one more map here up across the northern plains for the past 30 days. You can see up here far north central Wyoming, northwest Wyoming, parts of west central Wyoming have done very well. But look at this. You don't have to go very far. You go from 173% of average moisture there to 9% over a very short distance. Very extreme pattern, in my opinion. Have we seen them before? Absolutely. Will we see them again? Absolutely. Let's look at the forecast pattern from tomorrow through August 10th. We'll start out with the upper level weather pattern, all right? So there's your ridge of high pressure that's centered pretty much right there. What we've got going on here is just a pattern that's like this, right? You got a trough out here on the East Coast, and you've got one kind of up here in the British Columbia. But this high is really the main thing. What we need this high to do is simply break down considerably or possibly reposition itself. So let's put this into motion. It's a 5-day average sliding animation here, okay, over the next 2 weeks. So what this does is the ridge kind of shifts its way westward a little bit and then kind of comes back toward the four corners. But in the grand scheme of things, the pattern becomes a lot less amplified. And I think that owes to that ridge weakening, not going away by any stretch of the imagination, but weakening. So what that allows is some better opportunities for some northwest flow to come back here through parts of the Corn Belt and the center portion of the United States. Now, the forecast temperature in animation, all right, this is the 5-day period from the 27th to, August 1st, but you can see where we've got those high-end anomalies here and then also right down here, right? Big bullseye here in the Texas Panhandle, southeast and south central New Mexico, and also up here across the northern Rockies and the northern plains. But if I put this into motion, notice what happens. Do you see how that heat signal relaxes back here across parts of the, Mississippi Valley and into parts of the Corn Belt? That's because of a trough that's going to move through and kind of carve out some, not necessarily cold weather by any means, just cooler than where we've been. And I think that's something that will take place here in the middle part of the country, at least for a little bit. And then by the time we head into the latter part of the period, we see that pattern flexing again right here across parts of Kansas, western Oklahoma, and obviously into the panhandles. What about precipitation anomalies? Well, again, the 27th, or the 26th, I should say, through the 1st, we've got some rain chances in here. Tied largely to some of that monsoonal plume extending out of the mountains there. So there will be some rain chances coming up this week for that area there shaded in green. Areas farther south, probably not so much. Okay. Now let's slide this out like I did into that 5-day mean or average. And you can see kind of what happens. After we get past the initial 5-day period, we see dryness take over again here in the middle part of the country and not a giant response out here from the monsoon. Why is that? Well, I showed you the upper level weather pattern and the high is positioned about right there. If we had this high positioned somewhere over here, all right, we would get a lot more aggressive monsoon farther east like this. But with that high being back here to the west, what that does is just kind of create such an intense heat bubble that it allows that moisture with that seasonal wind shift to kind of come back here to the north and the northwest instead of shifting farther east. All right. A lot of times that can happen with this. We need that ridge to break down and or shift for a better setup for a lot of us. Forecast probability of an inch of rain or greater through August 10th. This is the forecast probability on that. All right, now obviously here in the mountains, back here where the monsoon plume is, all right, you've got a better chance. Areas farther east, you're looking at about a 60 to maybe 70% chance at an inch of rain or greater here, especially in eastern Nebraska, maybe southwest Nebraska, northeast Colorado. You can see those higher probabilities. But underneath where that ridge is having the biggest influence and where we don't have nearly as much moisture, you can see the odds right there. Through August 10th, a 0 to about a 10% chance of an inch of rain or greater here. Not good. Meanwhile, we have better opportunities coming through here. Not perfect, but better opportunities up here with that changing pattern. And you can go up here across Montana, pretty much all of Montana, 0 to 10% chance of an inch of rain or greater. And I didn't even mess with, the half inch or greater, because with this heat, it just doesn't do any good. It doesn't do any sustained good. And I know you know that. Meanwhile, we're also getting wetter over here because of that trough and some of the moisture that's going on. But that's what the next 2 weeks in terms of probability look like right there. And the European artificial intelligence is kind of on the same page with this. Again, the resolution isn't as high, but you can kind of paint the same general picture with what I was talking about. Let's look at the MJO here. The MJO, the way the European Extended is forecasting, all right, starts over here, red line goes through the null space, and then we pop out here, makes a pretty decent transition to come out here into weak phase 4, 5, and up here into 6. And some of these members, you see all those kind of yellowish lines, those are all different members of the model forecasting a very strong signal out here into phase 6. So there is momentum in the atmosphere that's taking place that will help to change and shift the pattern around a little bit. If we look at the Bureau of Meteorology out of Australia's forecast model, it actually does a quicker loop. It does something like this and then wraps itself back around here into phase 7 once again. So it does kind of a quick transition, pops out into 6 and comes back into 7. I'll draw all this together here in just a second. The GFS extended model has a really strong signal after it comes out of null space, comes out of here into phase 5, 6, and a real strong signal up here right through mid to late August into phase 6. What does that mean? Historically, when you look at the composite precipitation anomalies for June, July, August, and we're still in July, all right, after we get out of July, we can do July, August, and September. But right now, when you look at phase, say, 6, this is what shows up. And you can see there's more green on the map here, all right, across parts of the southern tier of the United States, not so much up here farther north. Phase 7, we shove that back here a little bit more, okay? Phase 8 has pretty much failed. We spent quite a bit of time in phase 8 over here, but phase 8 pretty much failed in delivering much needed water here from Texas all the way up into parts of the northern plains. So take it for what it's worth. A lot of times the teleconnections with the MJO and obviously El Nino are weaker during the dog days of summer, like what we have it. But that's kind of the MJO phase right now that we're locked into. And if we look at from a temperature standpoint, if you take it at just phase 6, look at where the cooler air is favored here, central and east. Is that what it looked like in the modeling? Not so much. All right. Phase 7, your heat is displaced farther northwest, just like phase 6. All right. Probably not going to be the way August plays out in this way. So that's why I'm saying you take it with a grain of salt until you see somewhat of a pattern show up that resembles this stuff. But it may be more like a phase 5 type signal up here where you've got all this, heat up here in the middle part of the country. And if you come back here to phase 5, you see dryness taking, really dominating here across parts of the Central Plains, Corn Belt, and areas east. But I'm not even ready to go there just yet. The European Extended model, looking at the forecast rain and temperature trends, this takes us actually not through the 8th of August. It actually takes us through the 9th, that 30-day period right there. The ridge is somewhat weaker, all right? And I know this is a 30-day average upper-level weather pattern, but The main core of the ridge doesn't look to be back here. It almost looks to be centered back here, a little farther east and southeast. All right. With some troughing taking place out here on the West Coast. And I know we're talking about even in the first week of September here, okay? But this is that 30-day period, from the 10th of August right through the 9th of September. If we look at the precipitation anomaly that's being forecast, you can see that this area in particular shows up drier than average for eastern Kansas, the eastern, most of Oklahoma, minus the Panhandle, the eastern 2/3 of Texas. Why? Well, if that high camps out over here somewhere, we bring that monsoonal moisture farther east than what we've been doing. Okay? Your flow kind of does that. So you reduce that dry signal for most of, at least the western 2/3 of Nebraska, the western half of Kansas, down here through the Oklahoma and most of the Texas Panhandle, and you place that dry signal here. Now, I always say, take this with a grain of salt because it's just a model, all right? But the model has been steadily forecasting this now for a while, that eventually, when we get past, say, the first 10 days of August, and we slide that window after that, that we have a much better response and a much farther eastward movement of some moisture that's potentially going to move in here. Now, I'm in the camp of, I'll believe it when I see it, okay? And I know that's exactly where a lot of you are. So I'm not saying that I'm confident that this is going to happen. I'm showing you a possibility here based on what the model has been trending toward. But it's been a pretty solid trend, at least in the short term. So we'll just have to monitor it and see where we go. Heat-wise, we're still warmer than average here in the middle part of the country. Is that possible? Well, I wouldn't be surprised to maybe see a little bit cooler anomalies show up through here, perhaps, especially if we can get more troughing here across the East Coast, because that warmth would be displaced a little farther west. Now, back out here, that's where your monsoon plume and subsequent cool anomalies are setting up. Areas farther east still look pretty toasty, especially underneath the core of that ridge, where it inevitably sets up out there across parts of the central and southern plains. Okay, let's look quickly at the state of the oceans and what's going on. I'm sure you've seen this all over the place. These are the current sea surface temperature anomalies. So what we have is a huge El Nino going on down here. This is, I would be surprised if this doesn't end up being the strongest El Nino of our lifetime. And I say I'm 51 years old, definitely the strongest one that I've seen, especially at this time of the year, okay? And it's not going anywhere, so it's only going to continue to strengthen. What we're also looking at over here is the Indian Ocean starting to warm up. We have this negative PDO signal, all right, that is right there. It's not so much right up next to the coast, all right? And we have a positive Pacific meridional mode right here too, all right? That's off the coast of the Baja. But here's what's happened over the past, say, 15 days. We've had continued warming down here in the ENSO region. We've had warming take place in this quadrant right there. We've had some warming take place in the Gulf of Alaska. So what I'm driving at, if you just looked at this map, would you say, well, wait a minute. Is the PDO starting to warm back up somewhat? Or where are we sitting with this? The other thing that I've noticed too, look at how much warming has taken place up here in the North Atlantic. Remember, this part of the ocean in the Atlantic was considerably cooler than average for a long time. We've seen a lot of warming show up in this subpolar cold region up here, all right? But what I want to do, I want to take it a step further, and we just look at how these sea surface temperature anomalies stack in reference to the global mean. Well, you still have that very pronounced cold horseshoe or reverse C of cooler than average water with this big warm blob right there. And obviously we have the real strong El Nino going on. That sticks out like a sore thumb. Over here in the North Atlantic, right now, some of the signal is a little bit mixed because of the intense warming that we've seen. The Indian Ocean is also kind of split. I expect that to continue to warm up, though, as we get deeper into fall. But if, and I've talked about this before, not only with my individual clients, but also right here in the Desert Farmer podcast, is that Is the heat and dryness out here in the middle part of the country in reference to this negative PDO, despite the fact that we've got an El Nino? Probably. And we'll have to continue to watch it to see how it develops. But if we look beneath the surface, this is just so impressive, and I know there's some warm anomalies even deeper than this, but the main warmth here, this is just amazing to see. Through several intense westerly wind bursts that have been blowing like this from west to east across the equatorial Pacific, we have transferred so much warm water, not only at the surface, but beneath the surface. And all of this warm water will continue to rise to the surface, not to the anomaly magnitudes that we have down here. This is a 9 degrees Celsius anomaly right there at around 140 degrees west, all the way down to about 150 meters deep. That is wild heat. All right. There is no reason, in my estimation, that this El Nino won't be a record setter because of all of this subsurface water that's so warm right here. But what I also want you to look at, and this is down the road, and I talked about this before, do you see how all of the warmer than average water has basically been evacuated from the western part of the Pacific? Remember, over here is Indonesia, okay? And you actually start to see some cool anomalies starting to show up here. What is the importance of that? Well, in this constant ENSO flux, all right, where we bounce back and forth from La Nina to El Nino and El Nino to La Nina and so on and so forth, like what we've talked about so many times, that whenever we see a big El Nino like this and a super El Nino and likely a record setter, once all of the warmer than average water gets evacuated to the central and eastern part of the Pacific, the West Pacific cools down over here. And a lot of times that can be a tell for the next phase of ENSO, that after this El Nino goes away, the odds of a La Nina developing are pretty stout. They're pretty stout. And for right now, I want you to, before I get to a little bit more on that, I want you to see what the old measuring device here, the Oceanic Niño index, shows for 2026 right here. We went from a negative 0.4 December, January, February, all the way back up to here at around 0 through the spring. Big push toward a positive 0.5 March, April, May, and then we tacked on another half 0.5 into April, May, June. The May, June, July is going to be a biggie. All right. So if you look the last time we had a strong El Nino with this negative phase of the PDO was 2023. And you can see that one wasn't nearly as strong as what we've got going on right now. And in late 23, it got up there to about 2.1, but this is going to blow that one probably out of the water and a whole lot sooner. So this event, despite that negative PDO signal, is a lot stronger than where we were in 2023, just based off of this metric. Now, if we look at the relative Oceanic Nino index, this was the updated version that came out this past spring. You can kind of see the same thing. So back here, we're basically 0.5 less than what the Oceanic Nino index measures. Still an impressive move, because we went from about a negative 1 December, January, February, all the way up here to positive 0.5. And if we look at how the atmosphere and the ocean are talking here, we can use the multivariative ENSO index and look at that. So look back in 2023. You see where we were? We had only managed to get to a positive 0.4 by May and June. And look at that, we only tacked on a little bit more than that right through September, October, before we made a push into bigger territory by November, December. So in terms of how the 2023 El Nino coupled and worked with the atmosphere, it wasn't that strong, despite the fact that the sea surface temperatures were a lot warm down there, okay? But this event of 2026, look at this move. We went from a negative 1 on the MEI in February, March to 1.5 May and June. We switched that a whole 2.5. Isn't that wild? Never seen something like that before. And you could even shorten that just a little bit and show that we went from a negative 0.6 all the way to that 1.5 just in that short a period of time. And we're going to continue to tack onto this. Especially for the June, July, it could be up there, around 2. It'll no doubt the fastest transition we've seen in not only speed but magnitude of our lifetimes. Now, what I was getting at before, with all the warmer than average water that's basically vacated the Western Pacific, we have to look down the road and see what could possibly lie beyond this El Nino. So this was the June run of the PSL model analogs. When we look at ENSO over the next several months, I mean the graph starts over here June, July, August of 26. There's December, January, February. All right, as we move into 27, and then over here is 2028. So you can clearly see all of these red bars showing a very high degree of probability that we remain in El Nino. All right, pretty much right here through April, May, June. After that, do you see these blue bars? Those blue bars are essentially La Nina probabilities. And where they cross over is right in the middle of next summer. You do see the gray bars in there, all right, that flex a little bit. That would be, neutral, basically, when you think of ENSO. But those bars basically cross over in June, July, August of 2027. And then we are likely off to the races for La Nina as we finish 27 and go into 28. I know this is a long way out there, all right, but it's something that we have to be mindful of, because after this strong El Nino gets out of the way, not only is the modeling suggesting in front of you here that we'll move toward La Nina, but history suggests that too. And it could be one of those double dip La Nina episodes too, because history has shown that to be on the table. I hate it, man. I hate it. I hate giving bad news. I've given more bad news over the past 28 years than good news in terms of what's going on. But this is what it really is important, that we capitalize on this El Nino in the places that El Nino is going to favor with moisture, because when we move into La Nina, it's not good for the Southwest United States. It's not good for the Western High Plains. It's not good for the Southern Plains, historically speaking. And I know some of you would be like, well, hell, it doesn't matter if we're in El Nino or La Nina. It's dry all the time anyway. I get you. And that's part of farming and ranching in the high desert of the West and the Southwest High Plains. What is important to focus on is that historically, for some of those areas, a big El Nino can mean big things. Let's look back through history here. What about 1972 and 73? That was also one of those years where we had a strongly negative PDO and a strong El Nino. So I went back through the Era 5 and analyzed this. So what we've got here is June, July, August of 1972, looking at sea surface temperature anomalies. Do you see that reverse C right there? Okay, right through here. And it's even more pronounced because we had a negative Pacific meridional mode right out here and a little bit warmer, all right? El Nino going on right here. That's what this is. A little warm pocket up here in the North Atlantic, but for the most part, the Atlantic was in a general cool state for the most part. And over here in the Indian Ocean, just kind of somewhat neutral, at least at this time. Now, what about September, October, November? We are still in that negative PDO mode, all right? Where you have that warm blob right there, negative PMM, negative PDO, big time El Nino down here, all right, that was taking place in the fall of 1972. Most of the North Atlantic was cooler than average, even down here in the main development region, all right? And December, January, February, we still had it. So, and we had a little bit of a shift here that's interesting. A little bit of a shift of the warmer water that set up shop right about there, all right, instead of hugging the South American coast. North Atlantic, again, cooler than average. Indian Ocean, dipole was a little bit warmer. But we still had that negative PDO and a pretty strong El Nino going on at the same time. And if we look back at that, at the Oceanic Nino index in 72, look at where we were, all right? We came out of that pretty good La Nina here. Look at the transition we made. By April, May, June, we were up there at 0.7, and look at us. We steamrolled here into 2.1 territory by later in the year. Now, again, we're doing this a lot faster, okay, than what we did in 72, but I wanted to show it to you. The relative Nino index made the same transition. In fact, it actually spit out a stronger metric over here in the late fall and winter time versus the traditional one. But you can see the movement here as we got stronger, especially late summer and into the fall. This is what happened, all right? June, July, August in 1972. Look where the dryness was really focused. Look at this. Is that how it's been? No, not so much. Look at the signal here for the most part. Here in the Western High Plains, even up here through, you can kind of fill in the gaps, if you will, but we didn't have a big problem, all right? Not a big problem through here. Areas farther east and southeast had a bigger problem. And if you take out that one upper low that came across Texas, about 10 to 14 days ago, our position right now would look a whole lot worse than probably even this would. But that's what happened, June, July, August of 1972. September, October, November of 1972, everything got wet in the Southwest. This is a classic El Nino look where you are drier up here from the Pacific Northwest, Northern Rockies, Northern Plains. This is a little bit of an aberration, all right? Down here across the Southeast and even in Florida was so dry in that fall of 72. But as dry as the previous 3 months were, a lot of these areas got really soggy in the fall, okay, of 72. And then if we go a little bit further here, if we look at December, January, February, so we finished 72 and go into 73, this is what ended up happening, all right? Southeast Colorado, northern, look at this. Storm track was a little bit too far south to benefit Colorado, certainly too far south to benefit areas up here. I think this climate division here around Cheyenne up toward Casper and into western Nebraska probably caught a decent snowstorm that missed out here in Colorado. Areas farther south did a whole lot better. Amarillo, Lubbock, Clovis, Hobbs, Midland, Odessa, San Angelo, all the way down here toward Del Rio, Laredo, those areas. And you were a little bit drier through this area right here. What about 2023 and 2024? Well, right out of the gate, you're going to see that the oceans look a whole lot warmer in 2023, June, July, August, than they did back in 72. You are absolutely correct. Okay? Absolutely correct. And back in 2023, we also had that negative PDO signal. You might say, well, what is this warmth that was coming up here toward British Columbia? The marker of what made the PDO so negative in 2023 was how warm we were over here and how less warm we were over here. Not cold necessarily everywhere, just less warm than we were over here. And what that does is that continues to perpetuate that negative PDO signal. We also had a negative Pacific meridional mode right there. In June, July, August of 23, look where the warmest of the warm water was, right there off the west coast of South America. North Atlantic was pretty warm. Most of the Atlantic was pretty warm in that fact. And then the Indian Ocean was starting to warm up. What about September, October, November? Same story, all right? A lot warmer in that area that I highlighted versus the area just adjacent to it. Again, it doesn't necessarily mean it was colder. It's just less warm. So it keeps that negative PDO footprint in place. We still had the warmest water here off the west coast of South America. Most of the Atlantic was still warm. Indian Ocean was warming up here, all right? What about December, January, February? Finishing 23, going into 24. we saw this become less pronounced, all right, but it was still there. Still a lot warmer here than where we were here. And some of that warmth started to shift a little bit away from the coast, which is typically the case. And we were cooling things down here, and our Indian Ocean dipole was definitely in a positive mode over here. So that's what happened in 2023 and 2024. If we look at the relative Nino index, all right, with that, all right, well, as I showed you before, this is what we did in 2023 and early 24. Here's where we are right now. So we are already considerably ahead with this metric versus where we were in 23. The MEI version here, all right, shows the same thing. Again, 1.5 there versus only 0.4. And again, we continued to strengthen it a little bit, just not what it was. But look what happened after the last El Nino event. Look at the double dip La Nina that took place. We went into La Nina June, July of 24 and came out of it March, April 26. Is that what I expect after this El Nino? Kinda. Yeah, kinda. In some cases, that La Nina to follow a strong El Nino like this can be very, very strong. Now, let's see the June, July, August precipitation that took place in 23. This was such a rock star of a spring, all right, and summer in a lot of these places, all right, all the way out here into the west. Look at this, though. Look at the monsoon failure, if you will, across Arizona, New Mexico in 23. We had intense heat and dryness here across Texas and New Mexico. Very, very wet. Wettest June, July, August out of that 134-year period across good chunks of Wyoming, northern parts of Colorado, and down here, even into southwest Kansas. We had all kinds of hail in this part, all right? Down here in parts of the Texas Panhandle, at least early, May was crazy, but then we dried out thereafter. What about September, October, November? Well, we started to dry some of those areas out and kept other areas wet. Drier out here. November, December, or I should say December, January, February, finishing 23 and going into 24. A lot of this was due to one very, very big storm. And even back here over parts of New Mexico, all right, I would say this whole area, okay, was under the influence of a very powerful early November storm. And they got another one that came through here too later. So that climate district was, again, all of those districts were skewed early because of that November storm, which wasn't included here, obviously. But we really turned things on during that 3-month period. So just to revisit things here, every El Nino is different. Strength, magnitude, nuances, whatever. What is this one going to do? To be honest, I don't think anybody knows right now, because the analogs with this are sparse at best. And also, when we look at the weather pattern forecast here, just based from the Euro, and I know I showed this to you 10 days ago, you're going to see some very classical things. And this is the upper level weather pattern from the Euro for August. And I'm going to kind of breeze through these again and show you. Ridge over the southern part of the country. There's September. We start to see a little bit of troughing, perhaps. Could be some tropical influence here. All right. But the ridge goes away. We are probably doing much more like this in terms of moisture transport. October, November. Look at December's change. Look at this. Huge Aleutian or Gulf of Alaskan low, flooding everything with Pacific air, strong subtropical jet ripping through here, all right? Meanwhile, we're going to have blocking that's going to take place up here. And what that's going to do is lock in this pattern, whatever it ends up being, and however far south the storm track goes, all right? But you can see the pattern there in December, and January doubles down on it. I mean, you can see the ridging here, all right, which would probably produce a little bit of a dry signal, obviously, here across parts of Canada, northern tier. But your flow kind of does this, all right, and you've got this ripping subtropical jet stream doing this. Wherever the heart of that subtropical jet stream sets up, that's who's going to benefit the most from this. But if you are looking for a cold winter across the board, going to be real tough to get it with everything coming in off the Pacific Ocean. It's not to say we won't see some cold air from time to time, but sustained cold, really hard to get for many areas with that. Temperature forecast. August, obviously the heat signal here. September, October, see the average to, less than hot taking place down here. That again starts that subtropical jet, cooler than average, not cold. Big difference. Cooler than average showing up here. Due to the clouds, precipitation, blowtorch up here. December, January. Now, this is due to the blocking that's going to be up over Hudson Bay and possibly Greenland. Some of that, we might shove a little bit more cool air southward, but look out here, we're still warmer than average. So still a long ways out there. Precipitation-wise, August was less than ideal on the European seasonal model when it ran earlier this month, but September changes that wholeheartedly for the reasons that I have mentioned. You saw that take place in the history of 1972 and 73 too, all right? October, November, December, and January. Really wet out here on the Pacific coast and really on both coasts here. Can you connect the dots like this or like this? Maybe. We'll have to wait and see. The NMME, there's your temperature right there in the middle. That's your hot spot, also up in the Pacific Northwest. September, October, November, again in response to the strong subtropical jet. December, same deal, blowtorch through here, classic El Nino. January, this is what's interesting to me, that we actually get some stronger, cooler than average anomalies in January down here, and they grow in February, and they linger even into March. Been quite a while since we have seen cooler than average temperatures farther south, and I am still in the same camp you are. I will believe it when I see it. But why is the model doing that? Well, because it still has a very locked in El Nino signal and a very active subtropical jet stream down here. The NMME precip-wise, August, there's your monsoon pop there. It didn't paint anything catastrophic out here in the middle part of the country, but I think what the message is dry early, maybe less dry later in August. But September, that goes away. Still a big monsoon pop here. October, real wet it shows in the plains. Drier up here. November, same deal. Drier northwest, very classic El Nino signal here. December, same kind of connect the dots thing that the Euro was doing. January, February, and March. Okay? I'm interested to see how this changes along the way. Right? Would that be great? Yeah, it would be great. It would allow us ample time to make up some of these moisture deficits that so many of us have before we may go into a less favorable pattern during the back half of 2027. We'll have to see. The Copernicus 3, temperature-wise, that's August, September, October, November, it's doing the same thing, December. And precipitation-wise, same deal too here. There's your big monsoon. There's your dry signal for August. We went over that 10 days ago right here on the Desert Farmer podcast, but there it was. But it goes away. See how it goes away in September? October, November, Notice where that jet is, though. It's a little farther south. You see the dryness setting up here? And the model doubles down on that in December and extends it a little farther south. Very classic El Nino signal. Climate Prediction Center. August, September, October. Temperatures. I don't know if I buy this. Okay. Where they're just average and only place this here. Might have to rethink this one. September, October, November, monsoon comes a little farther east, lingers, especially through September, has wetter in the southeast. Temperature-wise, same thing, all right? I'm not sure what's going to keep this stuff average to maybe even cooler than average in the middle part of the country based on the flow. So this might look different for them next month. Wet farther south, drier farther north. October, November, December, cooler south. I'm on board with this. All right. November, December, January, ripping subtropical jet, wetter south, drier north. And we get the blowtorch north and the cooler and the wetter farther south for that November, December, January, which makes sense. The IRI model, I think this is very heavily weighted for September, October, not for August. All right. I think what it's doing here is suggesting that September and October are going to offset what could be a dry August in some of those areas. That's why it's bringing that green farther east. Temperature-wise, not a whole lot to glean here, but you can still see warmer than average for most. September, October, November, as I said, look at how wet it is here in the middle part. Drier up here farther north. September, October, November temperatures, again, probably still warmer than average for most of us. October, November, December, just really stout wet signal here. And some of this here in the western high plains is also a very stout. That little bit of blue there puts it at 60% or above of above average precipitation. October, November, December right there. Take it for what it's worth. It's a model. But that signal is really strong from this model, to put it there. Temperature-wise, obviously there's a little bit of a cooler signal south, but most of us, no real cold air anywhere. For good reason, because like I said, everything's still coming in from the Pacific. And if you look at November, December, January, that subtropical jet continues to rip. Meanwhile, you are drier in that quadrant there. Real big difference from south to north here through the plains. I don't see any way around that with this event, especially once we get through late fall and into winter. And temperature-wise, we're cooler farther south, obviously, where we have more clouds, precipitation. Folks, I know that the modeling right there is a lot. And you might say, well, these models don't know a damn thing. And a lot of times you are absolutely right. But we're not looking for them to be perfect. We're looking for them to produce a signal to where we can glean some information from that and project going forward. And some of these stronger signals within the modeling, I think we can do that. Is this El Nino going to behave exactly like 72, 73, or 23, 24 did, or any of the other ones? No, it's not going to. The oceans are different. There's different gradients across the oceans right now that we have to watch. But one thing is for sure, El Nino produces extremes, whether it's flooding, drought, intense snow, intense heat or warmth during a particular time, and that will continue with this event. That deck is stacked in that favor. So what could theoretically happen is some of these areas that have basically had very little moisture so far this year could obviously flip the exact opposite extreme. Is that going to happen for everybody in the plains? No, that's not how these events always work. But it's on the table to see something like that. I showed you the evidence as to why. It just depends where that main subtropical jet really sets up as we round out summer and especially as we go into fall and winter. That, my friends, is going to be a big tell on who sees what. And we're going to start to see some of those tells as we get deeper into this forecast and as we start to go beyond summer and as we get closer to fall. So a lot of material today, Some of it was a little bit of a, a refresher course in case you missed the episode 10 days ago. But I hope you all are well. I greatly appreciate your viewership and your listenership. Please give me some feedback on this. All right. I never try to pretend that I'm the smartest one in the room on this. I know and have talked to a lot of experts, a lot smarter than me, that have their own thoughts about what's going to happen. And there are some out there that don't think anything about this negative PDO is going to mess with or supersede what's going on with this El Nino because the El Nino is so strong. So I think that's another element that we have to look at and pay attention to going forward. But I've taken enough of your time today. Thanks again, and I'll be chatting with you again real soon on the Desert Farmer Podcast. Be well.